Hi, welcome to your lesson on representing infinite sets. This is quite a big idea. Let's get this language down perfectly. There's a lot of different symbols and things you'll learn. Let's make sure we get it. Let's begin with what is a relation. We've been talking about relations versus functions. To recap, a relation is any set of points on a Cartesian plane. So let's say you had these points put on a coordinate plane. These are a set of points, and that can be called a relation. So to write this relation, we can write it as the set of all those points we see. These curly brackets are what we use in mathematics to represent a set. So by putting this here and here, we're saying here is a set of things, and here is a set of points that we see here. In this case, the points are finite. There is only, it looks like 8 of them, so we can list all 8 like that in one set. Okay, what about like this? We have another representation of a relation. A line is a set of points as well. There are many points on a line, right? There's some points. Okay, are there more points? Yeah, there's many more points. How many points are on a line? Well, actually, there's infinite points. And notice the points even go beyond the arrows here. The arrows on a line mean that the line continues infinitely in that direction and infinitely in this direction. So even though we see the arrows, it's not the end of the line continues. So there are all these points, infinite points along the line. So we have a set of infinite points. So writing that relation would be really tough to write it in set notation like this, because we're saying it's the set of that point and then another one. We would be writing those points forever because there's infinite number of those points. So rather than writing the set of all those points, we can just write an equation, and the equation represents all those infinite points. We can, for example, put any value we want for x, and when we substitute that value of x, we get a value for y that corresponds to that x value. So we can produce all these infinite points by putting in different values of x here. But again, we would be doing that forever because there's infinite points. All right, here's another relation. This is a set of points. It's a parabola. We studied parabolas in the last unit, but a parabola is just like a line. It's made up of infinite points. Here's many points on there, and there's infinite points. Again, there's arrows here showing the parabola will continue forever. So if we had to write the relation as a set of points, we could begin by writing one of the points, let's say the vertex, and dot, dot, dot. We could list all those points, but again, we'd be listing them forever because there's infinite points. So to avoid writing this set of infinite points, we can just write the equation. Much more efficient. That equation represents this set of infinite points, and this is the standard form equation of this parabola. Okay, how about this one? We have a square, and here we are looking for the set of points that are within or on the border of this square. So again, there are infinite points that can lie along the borders or within that square. There's infinite points. So we can be stuck again writing a relation as the set of all those points, but again we would be listing these points forever. Here's one, for example, negative 1, 0 is that corner. Another point in there, negative 0.5 and 0.25, so negative 0.5, 0.25, that point right here. But again, we'd be listing these points forever. So is there a better way to list all these points? Well, there's no equation for a square. So we're going to come back to this one later. After we see some things in this lesson, we'll come back to this one and see if we can write this set of points in a way where we don't have to list all the points. Okay, let's take some notes now. Grab your notebook. Let's add some key notes. First of all, when we represent infinite sets, we should be thinking about something called inequality notation here. So let's say we had x is greater than 2. Well, this can be represented with the shaded or purple line above the number line. So we can see x values greater than 2. This arrow means we can have any x value beyond there. So starting at 2 and beyond up to, well, you could go forever to infinity. So x is greater than 2. Notice that this is open. When it's open, it means it does not include that point. So it includes everything above 2, but not 2 itself. So 2.1 or 2.00001 would be okay, but 2 is not. We can write this in two types of notations in mathematics. One is called set notation, and it looks like this. So again, we know the set brackets already, the curly brackets, and set notation looks like this. We can say for x is greater than 2, x such that it means that we know that this set contains x values, given that there's a condition here. Okay, so all x values, but there's a condition. So this thing means read on, there's a condition, and the condition is x values must be greater than 2. If we didn't have this and we just said the set of x, it would just mean it can be any x value, but in this case we're saying no, it must be x values that are greater than 2 only, so it's that set of numbers. There's another way to represent sets of infinite numbers. It is called interval notation. Interval notation looks like this. We can say from something, comma, which means to something. Don't confuse this with one point on a coordinate plane. This is not a single point. This means from this number to this number. So if x is greater than 2, we begin at 2 and we go all the way to infinity. We can go all the way to infinity here, positive infinity. Notice that these square brackets are used now. This square bracket is turned out. That means we do not include 2, and we see that already here. And this square bracket is also turned out. That means we do not include infinity. Infinity is not a number, so we can never include infinity. So this means from 2 to infinity, not including 2, not including infinity. Another way to write interval notation is like this. So now we have rounded brackets instead of these square ones, and the rounded brackets mean not including. So this again means from 2 to infinity, not including 2, not including infinity. Okay, don't be confused by these notations that are used interchangeably. This one here, the reason it's often not used is because it's confusing. When you see that, you might be thinking of a coordinate, like you were to graph this single point. But again, this represents a set of points from 2 to infinity. Let's look at another one. We have x values less than or equal to 10. Okay, if x is less than or equal to 10, we can represent it like this on the number line. We go from 10 and below, less than or equal to 10. So numbers less than 10. Notice now this is shaded. It means we can include 10 as one of the possibilities for x. And that's what this says here, less than or equal to 10. So x can be 10 or any number lower than it, and that arrow would go all the way to negative infinity. Okay, so let's represent this in set notation like this. X is less than or equal to 10. X such that, so again, all values of x given this condition that x must be less than or equal to 10. So those are the values of x possible in this set. Alright, in interval notation, this one would look like this. From negative infinity to 10. So x can be any value. Imagine this arrow going all the way to negative infinity. So x can be anything from negative infinity all the way up to 10. From negative infinity to 10. And this time we have the square bracket inwards towards the 10, means up to 10 and including 10. And here we have it outwards again because we cannot include negative or positive infinity. Okay, using the other form of interval notation, we can write it like this. From negative infinity to 10. And again, you cannot include negative infinity, so rounded bracket, but on this side we can include 10, so square bracket. So notice that the square and the outwards turned square bracket and the rounded bracket mean the same thing. It means that thing is not included. But on the other side where we say included, we use the same on both sides. Okay, last one here. We have x is greater than or equal to 2 and less than 8. So now we have x is greater than or equal to 2 and less than 8. So that means x values are between 2 and 8, but this one's not included and this one is included. So now this one, for set notation, we can write x such that x is between 2 and 8. When you see it like this, it means between, so greater than or equal to 2, less than 8. So here, equal to 2, here, less than 8, but not equal to. That's set notation for that one. How about interval? Interval will look like this. X from 2 to 8, it includes 2 here, but does not include 8 because we have the outward bracket. In the other form of interval notation, we have this. X from 2 to 8, including 2, all the way to 8, but not including 8. And again, notice the outwards bracket and the rounded one mean the same thing. Alright, that's a quick introduction to our set and interval notations. And now let's just practice this a little bit more. And let's summarize as well. So here is set notation, looks like that. This means the set of x values such that, and then we have some condition. This means less than, this means greater than or equal to, and this means, we haven't seen this yet, element of the real number set. Okay, element of the set of real numbers. So when you see that, it means it can be any real number, so any number. Interval notation we had was if you go from a to b, we can write it like this also, and that means from A to B, not including. Remember, the round brackets means not including those numbers, and also the outward turned brackets can mean the same thing, not including those. If we write it this way, however, it means from A to B, including A and B, because the brackets are turned inwards on it. All right, with that, let's see if we can do some of these. What would this one look like? X is less than 3. Okay, in set notation, looks like this. X is less than or equal to 3, like that. X is greater than negative 4, looks like this. X is greater than or equal to negative 4, like this. X is between negative 1 and 5, how about that one? Okay, X is between negative 1 and 5, like this. Between always looks like this, so it's greater than negative 1 but less than 5. How about X is between 6 and 9 inclusive? What do you think that means? Okay, it looks like that. It's between 6 and 9 inclusive. It means it includes 6 and it also includes 9, so you have the equal there on each side. And X is all real numbers. So X is all real numbers means like this. So X such that X is any real number. Basically, this is saying X can be any number. Okay, how about the same ones in interval notation? Try both forms for the first one. Okay, there it is. X is less than 3. Notice it goes from negative infinity to 3 because it's less than 3, so it's all those numbers from negative infinity up to 3, and not including either one. Less than or equal to 3, so same thing, but now we have the square bracket turned in, and here also, because it includes 3. Greater than negative 4, okay, from negative 4 to positive infinity, because it's greater than negative 4, so it goes from negative 4 all the way up to infinity, and here, negative 4 to infinity. It doesn't include 4, doesn't include 4 also here, or infinity. And here, negative, greater than or equal to 4, so now it's turned in, it equals negative 4, goes to infinity. Or it can be written as negative 4 to infinity, like that. Between negative 1 and 5, what do you think? Here we go. Between negative 1 and 5, rounded brackets means it does not include, and here the same thing. And between 6 and 9 inclusive, okay, 6 to 9, both of them are square brackets included. And X is all real numbers. Check this out. From negative infinity to positive infinity does not include those because you cannot include infinity. Or negative infinity to positive round brackets also means not included. Great job. Try these. Okay, first one, check it out. And there we have that. Next one. Less than or equal to 4 looks like this or like this. X lies between negative 3 and 3, including negative 3 but not 3. Check it out, looks like this. Check your work carefully there. And X is less than 5 or greater than or equal to 6. Looks like this, or like this. Now let me introduce this, because this is something different. It says less than 5 or greater than or equal to 6. So less than 5, like this, right? From negative infinity to 5, because those are numbers less than 5. Or, when we see the word or in math, we can use this symbol, means union, or 6 or greater, it says, right? And notice they put the positive infinity here. You don't need to have that, but it's sometimes you'll see that. Okay, so again here, using the or symbol, that union symbol. And over here, we can just show it as two parts, less than 5, comma, or greater than or equal to 6. And last one, X can be any real number, like this, negative to positive infinity, or negative to positive infinity with the outward turned square brackets, and on this side X is element of the real numbers, and this one again should be really including the curly brackets on the outside here. Alright, great. Now that you got that skill down, you're ready for the next video. There is a second one that follows today, not quite as long, so please watch it now. It's about domain and range.